الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. Mr. President of the Conference, Congress and distinguished attendees, I'm Dr. Presantationofbenatallah2022 from the University of ALGERIA. I have the honor to present to you a summary of our work entitled Investigation of the effective pressure on elastic modulus of magnesium oxide up to 700 GPa by calculations. This is according to the following steps: introduction, study, method, results and discussion, conclusion. First of all, introduction. Magnesium oxide is an organic compound containing magnesium and oxygen in ion form, also known as pre-class. This name is taken from its synthesis, where it gained great importance for its entry into the formation of many minerals that form the Earth's interior, such as the magnesium wasted mineral, which has helped to form the basic structure of the lower Earth's mantle. There are many studies dealing with this oxide, as most of them are almost computational studies. Among the most important we find these studies included most of the properties with the oxide, mostly with a change in pressure and very little with a change in temperature. This work generally can be done by identifying the stable crystal structure and the phase transition of the oxide, as most of them show that there are two stable crystal structures for this oxide, each with special thermodynamic condition, namely the cubic structure of the type sodium chloride or the P1 phase, the cubic structure of the type cesium chloride or P2 phase. The phase transition at pressure is 400 GPa. But these studies were not interested in studying the rest of the elasticity coefficients, which are Young's modulus, Poisson's ratio, Lami's constant, and finally the microhardness parameter. Nor did they concern themselves with determining of the mathematical relationship to change this coefficient or any of the coefficients studied pressure change. In this research, we will be interested in determining the change in the values of elastic modulus up to pressure 700 GPa, with linearly determining the linear change constant for that variable. Second, the study method. Through previous studies, it was found that the study of works Hashmi et al. Is the most important given its comprehensiveness in terms of its study of most of the characteristics on the one hand, and on the other hand, we consider it here as a starting point for our study because it provided important values for the elasticity coefficient, volumetric modulus, and shear modulus, where this study relied on the method of DFT. Calculating the values of the rest of the required elasticity coefficient depend on the values of the volumetric compression modulus and the shear modulus, the values of which are available in the aforementioned study by the following relationships. Determine linear or non-linear polynomials that are close to the change of each parameter with the change of pressure by means of mathematical polarization, where the polynomials are of the following generally form can be easily programmed using the MATLAB development environment. Now let's talk about the result and discussion. The following curves represent the change of elastic modulus with the change in pressure of magnesium oxide in both P1 and P2 phases. Where we observed a non-linear decrease for both Poisson ratio and Lamy first constant with increasing pressure in the oxide phases. Quite the opposite with the rest of the transaction, which increase linearly with increasing pressure, and thus in tendencies, and they are follows as table 1 shows. Finally, we summarize the results in the following table 2. And in the end, the conclusion. Through this work, it can be concluded that all the studies in elasticity coefficient and constant increase linearly with increasing pressure. In a more precise sense, the studied coefficient of magnesium oxide in phase P1 and P2 increase with increasing depth in the ground, but except for Poisson ratio and Lamy first constant, they decrease non-linearly. Thanks you for good listening and following up.